Let's get your hands dirty for just a few minutes. You're going to do some Docker commands to run some basic applications with Docker. And in order to do that, we have a couple of setup requirements. Now, in the next section, you're going to learn about installing Docker on your particular operating system or maybe on a server where you want to run most of this course. But in this video, before we do that, because there's a process you have to go through, there's some reboots sometimes. And before we do all that, let's just use our browser and use a free service from Docker to spin up some containers on the internet. This is Play with Docker. Below me is Moby, the Docker whale. Actually, it's Moby Doc is his full name. He also has Molly Doc, which you will see around, who is a pink whale. And we're going to use this. It's actually labs.playwithdocker.com, which has dashes in it. And I'll put it right below that you can see that. So you're going to type that in. But in order to log in there, you're going to need to jump over to Docker Hub. There's only really one account with Docker. And you need to go over to hub.docker.com to sign up for that free account. Totally free. Allows you to log in and upload images and open source and do some things, as well as logging in to Play with Docker. The only reason we need a login to use Play with Docker is just to prevent people on the internet from misusing the free service, because this is why we can't have nice things. So jump over to hub.docker.com, fill it out. You really only need your email address, a Docker ID, or your username. That's important because whenever you're logging in, you're always going to use your Docker ID and your password, not your email address. So fill that out, remember your ID and your password, jump back over to Play with Docker's website, and you're going to sign in with the login button. So pause this video, go do all that, and come back here and push play. All right, do you have your Docker ID and your password? You're going to be using that throughout this course for various things, but for now we're going to use it to log in to Play with Docker. And over on the labs.playwithdocker website, when you scroll down to log in, if you've logged in, you will see the start button there, green, not blue. You click that and it whisks you away to an interface that in the background is going to allow you to spin up multiple Docker instances on the internet using real cloud services that Docker is maintaining for us. So if you click on Add New Instance over here on the left, right there. Click on that, and we're only going to create one instance for now. Later in the course, we can actually create multiple ones, set up a cluster, do all that. The one thing you have to remember is that these are timed out at 4 hours. So you can only use the same instances for 4 hours and then they just go away. So if we create Add New Instance, and we give it a minute for it to spin up a new Docker engine on a VM, and it's going to give us some information at the top, the IP address, the SSH, and we're not going to really use any of that just yet. What we want to focus on is down at the bottom, and I'm going to zoom in so you can see easier what I'm doing. Now, if we do a docker space version command here, you're going to get back two things, a whole bunch of details about the client and a whole bunch of details about the engine or the Docker server. And Docker is a two-part system. You're going to be using something like the Docker command line client, like we just typed, docker space version, and you're going to be talking to the Docker engine over one or more protocols. You might be using sockets by default. There's also the TCP connection that can also be TLS, and then you can also use an SSH tunnel if you're going over random internet as well. The point here is that the commands you type are in a client that has a version, and that binary is just called Docker. On Windows, it's technically docker.exe if you're on the Windows side of things. But in Linux, it's just called Docker binary. And then it's talking to the engine in the background that's going to execute through the API all these things we're typing into it. Now, back at our shell, if we type a new command, and you can type the word clear to get rid of everything else in the screen and put your cursor right back at the top. But once you're up there, you can type docker space run space -d for detach, which means we want it to run in the background, space -p, which means open up a port and publish it on my host IP so I can access it remotely. And we're going to run an Apache server. So we're going to choose port 8800 to listen to on our host. And then we're going to tell it to go into the container where Apache is running on the default port 80 that Apache is listening on. Then we're going to type in the image we want to run, HTTPD. That's the name of the Apache daemon running in the background. And if we hit enter, a whole lot of stuff is happening all at once. We're actually downloading the layers of the image, just like you previously learned, that makes up this full image. Then it's going to create the networking, create the virtual interface for the IP address. It's going to create the empty file system, load all these files from the image into that file system. And then finally, once that is all created, it will start the HTTPD process in its own little namespace where it's basically the only thing running. Now, if we wanted to prove that that thing's actually working, we could curl the localhost of this machine we're on, because we're running this container on this machine, and that's also where our command line is. So we could type curl to use HTTP to show us the web page, and we could curl localhost 8800 because that's the port we told it to listen on the host IPs, all the host IPs, including the public one and the localhost one, and it works. It responds with the default Apache web page, and we can even see that that container is running with a new command, docker ps. So that shows us a list of all the container processes running, and in this case, we only have the one. Now, there's definitely a lot of magic there, and I mentioned a few of the things it does, but there's a whole lot more. We'll learn a lot more about that throughout this course, but let's start another one. What happens if we run multiple Apache servers? We could even run multiple Apache servers of different versions, all with single commands. And because of the isolation and how Docker ensures that one app in its own container doesn't see or affect another app in another container, we can run that same command as long as we're using a separate public port. So that 8800 port, we have to follow the rules of IPs, right? We cannot use the same port on more than one application at the same time. So while the container itself gets its own private IP address that listens on port 80, it's when we use the -P, we're saying listen on the interface, the actual interfaces of my Linux host, and forward the traffic from the particular port I'm telling you into that container where the Apache lives. So if I simply hit the up arrow a few times and I back up and type 8801, slightly different port, then it will launch me a second Apache service, of which I can see if I type in docker ps again, I now get back 2. Now, if I had left that 8800 the same, I would actually get back an error saying that the port is already in use. Now, if we get a visualization of what we just did, remember earlier we talked about the Linux features of Docker running on top, and then we have this image. When you do the Docker run command, it downloads the image for you automatically. You could have done a Docker pull manually, but Docker run also does that for you if the image doesn't exist. So it pulls that down for us, and then it creates a new container when we type that Docker run command. So it creates container 1 with the HTTPD image, and then when we type it a second time, it creates another container, container 2, with its unique ID running that same image in a different process space that's isolated from the first. Now, when we publish those ports, we see that port 80 is the port inside of each container that's listening on the private IP assigned to each container that's unique, that is only accessible inside of Docker's virtual networking, which we'll talk about later. But when we do that -P, we're saying, hey, take this container and forward any traffic on the public port that I tell you about from the host IP into this container, which is why we can assign external port 8800 to forward traffic inside of container 1, and then 8801 traffic externally will then come into container 2. Now, this may seem a little like magic, or certainly a lot of automation, but it's really just focusing on major features of Linux and now Windows that are sort of adopting a lot of these Linux concepts. And you may have heard of a few of these. Namespaces and C groups I listed before, VES or virtual Ethernet devices. IP tables is like a firewall and general IP packet routing and control interface. And then union mounts, which is something that we use for getting the file system with all these layers in it into the container at start to look like its own unique file system that's isolated from the rest of the host. It seems like it's a lot of fancy, but when you log into a container, if you were to just shell into one of them, it would just look like a normal Linux file system with a lot less in it. All right, that's it for this lecture. I just wanted to give you a taste of what we're going to do later. You can always use the Play with Docker service. It should be available 24/7, but in future videos, we're going to learn how to get Docker installed locally or installing it on a real Linux server of your own. So we're going to have fun with that later. For now, you can click Close Session in the top left, and that will shut down the containers, free up the resources for someone else to use this wonderful free resource. Thanks, Docker. See you soon.